Okay, so, well, welcome to, you're in the finishing straight, right? And I know in a 3-day conference, your brain is sort of towards the end of the 3rd day, starting to dribble out of your ears, right? So it's after lunchtime now. So this is the snooze slot, right? So I'm hoping going to try and keep you awake. I've also got to stand here, otherwise the camera can't see me. So I'm going to try and keep you awake. I am going to, anyone here from outside of Australia? There's a few of you. I'm really sorry about the weather. It really sucks. I was in Ireland a couple of weeks ago, fully expecting this to be what was happening in Ireland, because it normally is when I go to Ireland, and it seems that we've just switched the weathers over. But it's been miserable here, so I do apologize for that. I can't do anything about it, but I do apologize nonetheless. I hope some of you have seen that NDC Sydney will be coming back next year. I'm on the programming committee, and we are very keen trying to make this a really great conference. We're still trying to work out how to adapt the NDC model for Australia. If you've got feedback, please do let the organisers know. Not just giving feedback to speakers, but just letting us know what we can do to make things better next year. But we're here to talk about deploying and scaling microservices. My name is Sam Newman. If you thought I was somebody else, you can leave now. You've got a window where it's acceptable. This is kind of a weird day for me. So I've been working for the last 12 years at a company called ThoughtWorks. I've probably done 150 conference presentations in the last 12 years. Before I joined ThoughtWorks, I'd done 0. And today is my last day working for ThoughtWorks. Literally, after this talk, I have to walk down the road, up Pitt Street, and go and hand all my keys back. So it's very weird. I've had a great time there in the last 12 years. I'm often a startup. But they are a great company, and if you need help on the stuff I'm going to talk about today, there are far worse companies than them to go talk to. Also, they're always hiring. And so if you're looking for a great career, if you're a grad to an experienced person, please do give them a call. You can say I sent them. I don't get referral bonuses anymore, so I'm not lying in my own pocket here. I also wrote a book called Building Microservices. I feel like I should also point out right now that I know this conference has a sort of healthy slice of sort of Microsoft-oriented technologies. I only have any Microsoft technology in my house so that I can play games that haven't been ported to Mac. So that's just caveating that out of the way. I'm hoping some of the stuff I'm going to talk about will be generally applicable, but just please be aware that I am not a .NET person. I am not a Microsoft-y. And so the last thing I did in this space was actually helping a company owned by Microsoft get off of Windows onto Linux. So if you need deep, dark details of the .NET stack in relation to this stuff, I will do my best. But please do not be surprised if I go, so we'll see how that goes. We're going to talk about 3 things today. We're going to talk about some core principles around how we want to think about packaging up and deploying our microservices. So microservices are interesting things. People seem to like them a lot. People keep buying my book, which I'm very happy about. I can give you bulk discounts if you want to buy them in 20 or more. That's fine by me. But there's they're nice conceptually. They're a nice idea. But people actually struggle knowing how to actually go about deploying them. And actually some basic stuff around packaging them up gets quite interesting. So we're going to talk about some core principles around deployment of microservices that should stand you in good stead no matter what platform you use. Once we've gone through that, we're then going to look at the actual types of artifacts that you might want to create. And then based on those artifacts, we're going to take a look at 3 different deployment platforms that many people have been using for deploying microservices. Now, I think this is going to be useful, I hope, not only in getting some insight into the 3 platforms themselves that I'm going to talk about, which are Kubernetes, Mesos, and Docker Swarm, but I'm hoping more generically it's going to be useful because I'm going to give you some criteria to think about when analyzing other types of platforms that you might want to use for deploying microservices. You may not have access to those specific technologies. You might be looking at other things. You might be looking at Heroku or Pivotal Cloud Foundry or whatever else, but hopefully you should at least come out with some concrete questions to ask of the next suited and booted vendor that walks through your front door. So let's start at the beginning. Let's talk about core principles, and let's start with the basics about what microservices are. I draw them like this. I draw them with hexagons. It's a nice shape. They have names on them. I have my services. I want them to be modeled around business domains, around business capabilities. We've seen that by doing this, that we end up with more stable service boundaries, because changing service boundaries is expensive. And we also expose seams that make sense to be exposed, rather than just exposing arbitrary technical boundaries. If you want to know more about modeling those, I've done other talks in the past, or you can take a look at the book. In terms of this talk, the thing I want you to focus on, and probably the most important principle to embrace when using microservices, is actually this one, that these things should be independently deployable. It should be the norm, not the exception, that you can make a change to a single service and deploy that into production without having to deploy anything else. This is what gives you the ability for teams to own services, to have autonomy about their release cycles. This is how you reduce your cycle time. This is how you keep the scope of your releases small, keep the risk of those releases small. If you're in a place where you're having to do lockstep releases, you're going to have large scope releases. Those large scope releases will be scary. Because they're scary, you take more time around them, which means you have longer between the releases, which means the releases get bigger, means the releases are scarier, so you take more time around them, and so on and so forth. And when they fail, you end up with more problems because there's a larger scope of change, so it's harder to track down what failed. The secret is in all of this is not a microservice point, actually. This is a monolithic systems point. Keeping your release batch size as small as humanly possible is one of the best things you can do in terms of releasing software frequently and safely. And with microservices, it's no exception. But the key thing is, if you have a situation where you're releasing multiple services in lockstep, you are probably in a world which has significantly more pain than if you had a more monolithic architecture. So, independent deployability. So we're going to be looking at platforms and deployment techniques. We're going to be thinking about ensuring we have that criteria, that we can deploy our services independently of each other. We also need to give some thoughts, though, about how we actually get our software to where it needs to be. How do we go from a laptop to a live environment? Most of you have a laptop. Actually, it's kind of nice now. When I first started working at ThoughtWorks, my laptop was a Toshiba Tecra. And at my first client, they got burgled. And everything in that office got stolen, apart from our laptops, because even the burglars took one look at those things and thought, yeah, no. But now I can actually develop, right? I get a very powerful machine here, but it's not a production machine, right? So I've still got to work out how I go from here to here. And this is when we start thinking about things like build pipelines. Whether or not you're explicitly modeling these or not, conceptually, we have this idea that there are multiple stages involved in taking software out of my hands and moving it through into a production environment. Many of you, actually hands up, how many people here are using some sort of continuous integration process? Right, probably all of you. Some of you might even have to use TFS, but that's your own fault. It is amazing. It's actually, TFS is legitimately bad. At least, my experience of a couple of years ago. But it's surprising how many people use TFS, not because they wanted to pick the tool they wanted the most. They picked TFS because they had an enterprise agreement with Microsoft, and they didn't have to pay for license fees. That's a terrible reason to pick what is a vital piece of infrastructure. Hopefully, it's got better. But, anyway. So here I have my laptop. I've checked some code into source control. I then have some kind of CI process that detects that check-in and can then trigger some automated processes. Normally, the very first thing we're going to do is something like, build the software and make sure it compiles. It's surprising to say this, but a decade ago, I did most of my time when I first joined ThoughtWorks, for about 5 years, was doing continuous integration, infrastructure automation, and a surprising amount of that were going to clients and just helping them make sure that when they check the code in, that it compiled together before we even start worrying about tests. So we compile it. And then what we would normally would do here is we would actually create some kind of artifact that we are going to deploy. So we bundle our code together. Right, we'll talk about what those actual artifacts might look later. And then we take that artifact and we move it through these stages. And again, you might have a CI tool or a continuous delivery tool that allows you to model this workflow, or you might just have that in your head somewhere, or you might have a release manager tracking it. But conceptually, we're taking this software that we've checked in, and we're moving it through these stages, saying, yes, Are you good enough? Okay, the automated tests have passed. Now we're going to do a UAT cycle. Did the UAT pass? Are our users happy? Right, maybe now we need to do some performance tests. And if the performance tests for that version of the software pass, we will push it into production. Some people, this is an entirely automated process. That's what's called continuous deployment. So a check-in is validated for a number of steps, fully automated, hands-off, and so you have a large number of those check-ins will go straight through to production. Things to think about when you have this process. What you want is you want one artifact for all environments. The reason for this is twofold. Firstly, rebuilding the same artifact from the same version of the code over and over again for different environments just wastes time. And that's kind of odd, right? Why would we do that? We want these things to be fast. The second reason you don't want to rebuild artifacts for different environments is because problems can creep in. We want the version of the code we ran the tests on to be what we deployed, because if we rebuild our software and maybe pass in some different compiler flags, we can change the behavior of the software such that we will unearth problems in production that we really should have picked up at tests. So we want the version of the code that we ran our tests on, the artifact we ran our tests on, to be the thing we deploy. We also want to have the same deployment process everywhere. We would like to have the same deployment process in production as we use in performance, as we use in UAT. And again, this is because we want to find problems early. I would like, during my test cycle, to have used the same deployment process I'm going to use in production. Because if there's a problem with the deployment process, I find out then, not in production. So all the platforms we're going to look at are going to help us with these things. They're going to help us in terms of having one artifact for all environments, and they're going to help us in terms of being able to use the same deployment process everywhere. It's probably as a sidebar, I'm a CLI guy. I like my command line interface. I like dashboards and GUIs for viewing things, but in terms of carrying out actions, I like having a CLI available to me because I can script it, I can share it. Obviously, we've got chatbots now, which is effectively just a shared communal command line interface. This is the deployment script I strive for in any company, in any situation I'm working in. I want something that looks like this. We have the name deploy. That's a good name. It's sort of action. I know what that means. That's great. Then I have the name of some service. This is the returns service. Okay? The next parameter I'm giving it, this script, is some version identifier. This could be a build number. This could be a tag, a name, some way of finding out which version of the software you want to deploy. Normally, I'll want to support local, which means it will be the version of the software I built locally in my machine. Or maybe latest, which might be the latest green build, so the build that's got through far enough through my build process. Or it could be an explicit version. And finally, I'm going to give it an environment. And an environment is a place, it's a location, it's an isolated set of resources and data where I deploy my service potentially into different topologies. So this is the idea that I might have a smaller, cut-down UAT environment, which is just there for people to poke around and have a look at, or a very fully-fledged performance environment. So my UAT, maybe my service is just a couple of nodes load-balanced on a single database instance. I'm trying to keep my environment smaller. It's less work. I save some money. It's faster to provision as well. We're always looking for fast feedback. Whereas in production, my production setup may be actually a primary replica database, 4 nodes load-balanced across 2 data centers. So this is kind of interesting, though, because this is a very familiar thing. I think many of you will see this idea that your environments have very different topologies. But I said earlier that I want the same artifact for all environments. And this becomes a problem, because the way people often solve the environment issue is what they do is they create different artifacts for different environments. And I think for my approach to work, you need to separate out those two concepts. What you want is a universal artifact. When I say I want to deploy what version 1, 2, 3, 4, 5 of my code, there is one artifact for version 1, 2, 3, 4, 5 of my code. What I need a way of is defining the topology separate from the artifact. And again, all the things we're going to look at later on allow you to have that topology and that configuration stored separately from that core artifact. And at this point, again, nothing microservice specific. These are exactly the same principles I've used for building deployment for the last decade. So core principles for microservices, independent deployability. Make a change to something, deploy it into production in isolation of everything else, and if you can't do that, get good at that before you add anything else, before you add a second service, before you add a third service. One artifact for all environments, and use the same deployment process everywhere. So let's go on to what I think, this is the Marmite topic, really. Well, I should say Vegemite topic, although Vegemite is awful. So really, I'm a Marmite fan. We've had these conversations. And then recently, Coles delivered Promite to our house as a replacement. We couldn't work out what it was a replacement for. We think it was for the floor cleaner, because that stuff is vile. Anyway, some people love this stuff because it's a bit, I do, because I'm like a sysadmin opsy person. This is great, you know. Other people go, oh, is this interesting? But actually it is. Bear with me. It won't take long. Artifacts. How do we package our thing up? What is a thing? What is the artifact we want for our services? What can we do with our things? What do we want from an artifact? Well, you know, we'd like it to be easy to create. We want simple build processes. We want simple packaging processes. Simplicity is good. We've got enough problems on our hands if we're building microservices because we've got to deal with cap theory and physics. So let's keep our packaging simple, nice and easy to use. We want to make it easy to deploy. Turns out some of the artifact types that are easy to create actually push problems into the deployment space. We want something that allows us to abstract out the underlying technology stack. In a microservices world, this is important because often what you're doing with microservices is you're trying to give yourselves more options. You're giving yourselves the ability to try a different technology in a different service. It's actually a nice way of sort of incrementally adapting new ideas into your organization. With a monolithic system, you tend to get to make one choice about technology stack, idiomatic style database. Microservices, you've got the option to say, let's try something new here. The problem is if every time you do that, you have a fundamentally different deployment process, your whole deployment process gets quite complicated and difficult. And so ideally, you want an artifact type that sort of hides away the detail of what's happening under the hood. And we also would like an artifact type that is good for developers and also good for operations people. You may be one and the same person, or you may not. A lot of the time I see artifact choices are driven sometimes by what's easy for developer people. And then operations people take a look at it and go, this is horrendous. They then create a different artifact type for their deployment processes. And what you end up with is one deployment process for developers and a different deployment process for operations people. And we're back to this problem where operations people find problems later on because development people aren't using the same process as them. So something that's good for both. So let's start at the beginning. Let's start with tarballs. Giant bundles of stuff. In Linux, we'll say a tarball because we use the tar command. This could be a zip file. Now, just like oil leaks, you know, where you get like a load of seagulls that sort of become meshed together in oil, and then people die in those things. Tarballs aren't always good because their thing is they're really messy. The reason we have these zip files or tarballs of destruction is because one reason and one reason only, they are very, very easy to create. I just do some compilation, and I go, yeah, I'll zip it up, that'll be fine. And then normally what you do is you load that up onto the magical catapult of doom and catapult it across the yawning chasm between you and the poor bastards that have to deploy this thing. And they receive it as willingly as gulls receive an oil slick. The problem here is that I don't actually create easy to deploy outcomes. You've packaged a whole bunch of stuff up in the zip file. When you actually want to deploy it, you often have to move files into different locations. You might have to change ownership and permissions of who can sit where. You may need to change execution flags on those sorts of things. What often you see with sort of zip file or tarball-based artifacts is then a lot of work in the scripts to open things up and move things into the right location. This is where people start using loads of PowerShell, Puppet, Chef, or Ansible, because the artifact types themselves have lots of work that needs to be done. Sometimes they can abstract out the tech stack. It's a bit agnostic. You can do good jobs of that, you can do not good jobs of that. Are they good for devs and good for ops? I'm sorry, I'm a semi-ops person, and I think these are a terrible idea, and I hate them. And if, when was the last time you wanted to try out some software on your machine, and the process was download this zip file, copy these files, you would know, or do something else. You want a nice, NuGet install command line, right, for your own stuff on your own laptop. Why don't you want the same things for your production systems? So don't do this. Let's look at other options. Well, there's a whole bunch of tech stack specific types of artifacts that can be useful. Think of things like NuGet packages, pips, NuGet packages, jar files, pips, gems, the like. Some of these can work for services. Some of them are more fraught. A lot of these packages are often really built with shared libraries in mind, right? Shared code. This is your dependency management, your package management. Not really built with service deployments in mind. Some of them can kind of work, but they're all a little bit iffy. They tend to be somewhat easy to create because if you know that technology stack, you often know the tool chain, therefore know how to create the artifacts native to that tool chain. They're not always easy to deploy, though. Any of you here are Ruby? Anyone do a bit of Ruby around here? No, they're a couple of people. I thought they kept the non-Microsoft stuff downstairs. But there's a whole host of really interesting problems associated with trying to deploy gem files into production systems, because a lot of the Ruby packaging deployment tool chains actually open up interesting security holes on your production systems. So this is a bit different. They obviously don't abstract out the technology stack, because by definition they're technology stack specific, these deployments. And by definition, I'd say also they're not really good for dev and ops, because ops people suddenly now have to become an expert in whatever tech stack they are to get up to speed with the tool chain that you've decided to pick. It's less of an issue if you're very homogeneous, right? If you're going to be just a Ruby shop, it probably makes a lot of sense for your ops people to be really good at just knowing how to deal with these sorts of things. Now, I will, of course, say at this point that there is one technology stack out there that obviously has the perfect form of tech stack specific packaging, and that is Go. Because everything in Go is awesome. It's just the best thing in the world. Obviously this is the most buzzword friendly talk here at NDC, and I felt it would be remiss of me not to say Go and Docker, Go, Docker, 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 Go, Go. Microservices, Go, Docker, Microservices, Go, Docker. Go is actually kind of interesting because the native form of packaging in Go is a statically linked binary because of the way the packaging is handled. They actually tend to be very, very small, tiny little binaries that are completely self-contained. And that's kind of interesting because they're actually quite easy to move around and they're actually easy to deploy. But it's just like copying binaries around still feels a little bit hinky to me. And of course, if you think about a service deployment, you'll still need to register that service, put start and stop scripts in. But anyway, Go is kind of fun, though. Anyway, so let's skip over that one as well, because I don't think that's a good choice for us. Now, here's one that's often overlooked greatly. Turns out, most of us are using an operating system that has natively a very good mechanism for installing software that just kind of works. Like, we're talking here about the operating system specific packaging tool chains. How many people here have done something like this? Logged on to an Ubuntu box, just gone install this. Maybe you've done a homebrew cask install, chucked in NuGet install. These things kind of work, right? They handle fetching the right version of the software. They handle installing dependencies that we rely upon. And actually, if you look at this isn't that different from that, is it? I've got some go get me this thing. I'm only really missing these two flags, and those are actually easy enough to pass through as variables if you want, or in wrapper scripts. It's not that hard to do this. These kind of are really nice and easy to use. So why don't we do it? Well, often because we fall at the first hurdle. Creating these operating system specific artifacts is, in general, not easy. Hands up how many people here have tried bundling .NET services as MSIs? A couple of people? Hands up who thinks that was fun, right? So in the Linux space, packaging managers are just as difficult to work with. They're all a bit different across the different platforms. There is actually a package manager, which is kind of a meta package manager called FPM, which sort of tries to sort of simplify the process and supports multiple different underlying Linux platforms. And it simplifies the process by only supporting about 50% of what you can do with the underlying things. FPM stands for Effing Package Manager, which gives you an idea about how painful these things are. So we don't tend to put the work in, and it's a real shame. The problem is, it's pain now, and so we avoid it. But I think if we bear that pain, we really do get the benefits, because once you've done that, they're really easy to deploy. We've all used the command line. The developers know those command lines. The operations people know those command lines. Even more so, you have support tools around these things. So on Linux platforms, for example, I can do things like, check signing of those packages to make sure I'm not getting wrong packages. I've got tools to tell me if I need to patch those services. And it's fantastic. We have this whole supporting tool chain and infrastructure that we're not using just because we're too lazy to package them properly in the first place. We also completely avoid the need for all these scripts to move things into the right places, because all this packaging software, all these packaging formats allow us to define things like what users these things will run as, what permissions the file should be, what locations these things will be inside the package itself. There's no need now for elaborate chef or Puppet configurations, because my Puppet config, my PowerShell config just becomes install this package, this version, make sure it's installed, done. Not pages and pages of setup and configuration that you've got to debug and keep fresh. They abstract out the technology stack as well, right? You don't care what's running, as long as something launches on that port. I don't know what underlying language most of the stuff I run on my Linux box is written in, but it works, so what do I care? Good for devs, good for ops. Well, I think ops people love this stuff, or go crazy for this stuff. Devs don't, often because developers don't work on the same operating system as production systems. I mean, even those of you in the Windows space, that's probably the case, right? A lot of you will be deploying onto a Windows server. You're actually developing, some of you, on Windows XP still. It still happens. 75% of all the ATMs in Australia still run on Windows XP. It's the smartest thing I think Microsoft ever did from a bottom line point of view was end-of-lifing support for Windows XP, because it meant all the banks in Australia have to go and negotiate on a per-client basis support agreements with Microsoft, and they know they can't change. The last bank I worked at, just down the road here, all the devs had these lovely MacBooks they were getting given, and they opened the lids, and it was running Windows XP, and that was just last year. Anyway, so that's the problem. So we don't, because developers are often in charge of doing the initial build scripts, they don't put the effort in to make them easy to create, so they don't do it. They just punt on it. They don't know the tool chains. They don't see the value. The operations people would love you for this stuff. They really would love you for this stuff. They really will. It doesn't solve all our problems, though. We think about what happens. Okay, I have a build process. I check in some code. As a result of that check-in, I generate brand new artifacts, and I store those artifacts. Let's imagine I'm using my OS-specific artifacts. I'm going to store that probably in some kind of artifact repository which is specific to your operating system. So I'm not quite sure what the equivalent is in the .NET space, but it might be a deb repo or a yum repo for, say, CentOS and Red Hat-based systems. And that's great. And so when I want to deploy my service, I bring up a host, or maybe I just log into a host or whatever it is, and I run my command line, and it pulls down that version of the software and runs it locally. The issue here is, of course, one of the things we talked about earlier is we want independent deployability of these things. And sometimes we can have a whole bunch of situations where deploying more than one service onto the same host, be it a virtual or physical host, can have issues, can have collisions. Let's think of a simple example of the kind of collision that we can have when deploying more than one service onto the same host. I said before with the operating system specific artifacts that you can do things like define the dependencies that you have. As in, for this software to run, for my service to run, I need these other things on this machine. So in this example, the green service needs version 1.5 of a thing called A, and the blue service needs version 2.1 of a thing called A. Sometimes this is okay, and they can be kept separate. A lot of times they can't, especially if what you're relying on, for example, are incompatible subsystems that need to run that same system. So you often have to really understand what the transitive dependencies are of these systems. It can be quite challenging. Anyone here who was deploying JBoss apps in the 2000s will remember a lovely thing called the unified class loader, where you would just get random different classes assigned to you if you had more than one thing in the application container, which just blew my mind. So you sometimes get collisions here. And that's just because there is no isolation. So we've got a bit of risk now associated with deploying more than one service in the same place. Likewise, we have the same problem from a point of resources. I check in a new version of the purple service, and there's a bug in the code, and now it's significantly more CPU hungry, significantly more resource hungry. And on that host, it basically consumes all the resources, and thereby all the other services on that machine stop working. And so we have a situation here where that lack of isolation between those services causes problems during deployment. This makes people less confident that they can release independently. This is why most organizations that have been using microservices for a while normally end up in a situation where they have one host per service. At Netflix, for example, their hosts they have very big Amazon machine images, like 64 gig VMs, because their services are very big as well in terms of the amount of traffic they handle. Other places, this is more difficult, right? If you take, say, an app with fairly modest resource requirements and you break it into smaller parts, those smaller parts themselves have even smaller resource requirements. And this becomes a difficulty because that can get quite expensive. We'll come back to why in a moment. But nonetheless, this is a nice idea, right? We have now isolation. I've got my host. I'm only deploying one service on that. I don't worry now about there being other services, other dependencies that could collide with other services. I don't worry now about using up all the CPU on that service affecting anything else than that service, and everything else is protected. This is a great model. This also opens up then a new kind of artifact for us. Because normally you don't do that on physical machines. Normally you're deploying it onto some kind of virtual machine technology. You're taking your big physical box and you're breaking up into little parts. That then means that what we can start thinking about is packaging our services as custom virtual machine images. So taking the operating system and the service, the actual service code, and saying, rather than the artifact of deployment being my Java application, my .NET application. Instead, it's my .NET application on that operating system, packaged up as one binary. So realestate.com.au over in Melbourne, Netflix, loads of the Amazon people will do this quite routinely. They'll create what's called an AMI, an Amazon machine image, out of their build pipelines. There's some really interesting reasons why this is a good idea. The first thing, actually, is that it allows you to synchronize sort of provisioning of the infrastructure itself and the service. So now rather than thinking about, okay, so what I'm going to do is I'm going to bring up a host, and I leave that host running around for a long time, and I just deploy newer and newer and newer versions of my service on it. Over time, this thing has been around for a long time. It kind of works, but you're not quite sure how. People have logged in and monkeyed around with the box. You can never really recreate that state. It's quite difficult to look after. In this world, when I execute and launch my image, it's a brand new machine. That means I can be very sure that that machine has been created from stuff that's actually checked into source code, which means I have reproducible builds. This is how you go from pets to cattle in the cloud world. These also provision really fast as well. They're not always easy to create, though. So the AMI toolchain isn't too bad. There's Aminator from Netflix that can help you build these things. When you start getting into other virtualization platforms, though, creating these custom images can be really painful. The VMware toolchain certainly sucks. Now, HashiCorp, who do some awesome tools, one of the tools they create is a thing called Packer. Packer is sort of like the FPM, is like kind of a meta-level virtual machine image creation tool. So it can create virtual machine images for DigitalOcean, I think Joyent Cloud now, VMware, vSphere, and a whole bunch of other virtualization technology. And that can be quite useful because it can also create vagrant virtual machine images which you can then run on your laptop in sort of isolated environments. So if you are interested in custom images and you're going to be supporting more than one platform, definitely look at Packer. Easy to deploy. Again, this can vary. So with Amazon AMIs, when you create that AMI, it's in the cloud. You only ever reference it by pointer, effectively. You pass around an ID. When you create a custom VMware image, that could be several gigabytes in size. If you've packaged up, say, a Windows OS, that could be 20 gig. Your network ops people are not going to like it when for every CI build check-in, you're creating a 20 gig VM that you're then moving around on their networks. They get cross about those things. So again, this can vary. They are excellent at abstracting out the technology stack, though. You just launch the thing, and your service is already running. You don't even know what's there. Good for devs, good for ops. I think they're good for operations people. You're turning on an appliance. Your whole application now is just a series of appliances that have a fairly well understood state from an operations point of view. From a developer point of view, though, you have to be careful. You have to have other ways of launching the application because the life cycle of creating these things can take quite a while. So this is good to a point, but VMs are not free. Virtualization isn't free. And the analogy I can think of is like imagine that your physical machine is a drawer, is your sock drawer. And you come in and you look at your socks, and your socks are everywhere, right? They're all mixed together. Your red socks in with your blue socks in with your green socks. You think, I'm going to bring some order out of this chaos. And you get some wooden dividers, and you put those wooden dividers in your drawer. And you've got nice compartments. You can separate things out. They're isolated. It's easier. Do you have more space or less space now in your sock drawer? You have less. The dividers themselves take up space. Not a lot of space, but they take up space. The dividers you put in to give you more small compartments in your drawer, the more dividers you put in, the more proportion of the volume of your drawer is going into dividers, and the less space is available for socks. Most of the virtualization technology we use has similar issues. As you further and further subdivide a physical machine into smaller and smaller VMs, more of the resources of the machine itself are going to ensuring the isolation of those resources than actually being used to run your services. This can mean that it can be very expensive to have lots of small VMs. This is actually the reason why people have got interested in Docker. I think developers get interested in Docker because, oh, look, I can run a command line, and I've downloaded like 15 untrusted pieces of code onto my production system. Friends don't let friends install stuff from the public Docker hub. It's like finding a USB stick in the gutter and just plugging it into your machine and going, I should be right. The reason it's great is because this Docker gives you a nice tool chain on top of container technology. And container technology is subtly different from virtual machines. With virtual machines, most of the virtual machine technology you'll use will have a thing called a hypervisor. That's sort of a separate subsystem that ensures isolation between resources. Those virtual machines themselves have a full operating system stack, a full operating system kernel, and that's taking up more resources as well. Container technology works by having one single operating system kernel, and effectively, the kernel manages isolation of resources. So you can kind of think of it like branches on a tree, and each branch is a separate container, and so you have one kernel. So that's really nice. So you don't have the overhead of the hypervisor. So that means your cost of isolated hosts is drastically reduced because more of your resources are running your services than running the isolation, which means you can get away with smaller, cheaper machines, much more cost-effective. It's also quite easy to run this stuff. You just download Docker and run it, and it kind of works. It's a lot less setup than some of the other VM technologies, and resources are lower as well. These things are also blindingly fast to provision. Container technology in general is much, much faster. Spinning up a full-fledged VM on Amazon, which is not bad, it's certainly faster than some, not as fast as Google, but faster than Azure, is going to take you a couple of minutes, right, spinning up a decent-sized VM. 2 minutes. Still pretty good, but 2 minutes. I hit enter, and I'm expecting, even before my prompt has actually returned, a container should already be provisioned. We're talking milliseconds here, fractions of a second here to provision containers. When you log into Gmail, Google spins up multiple containers just for you on demand to handle your inbox, right? You're not waiting 2 minutes for your inbox to render. So these are great, really, really fast. Are they easy to create? Well, so the key thing to understand about Docker is effectively a set of scripts on top of container technology to make it easier to use. Are they easy to create? There's a few gotchas, but actually I'd say it's easier than creating custom VMs. Easy to deploy? Yes, the tool chain around Docker is really, really nice. Do they abstract out a tech stack? Do a very good job of that. They're the same as custom VMs in this way. Are they good for devs and good for ops? Here the issue mostly is developers love this stuff, right? Operations people are like, there's a whole load of tool chains that I don't have now for running production operations. And one of the biggest issues here is actually managing Docker across multiple machines. The core Docker tool chain is really about single machine management. And so when you want to go across more than one machine, as you're very likely going to want to do in a production environment, you need to bring in other tools on top. And that's what we're going to look at next. So we're going to look at some platforms that allow us to take images, Docker images, and sometimes other things, and handle those well across multiple machines. So again, what do we want out of our deployment platforms? I'm going to give you three. We're going to compare three. But there are loads out there, so I'm going to give you some sort of core things to think about when looking at the platforms you want. As we mentioned before, we need something that allows us to separate our artifact from the environment topology. We need something that makes handling these things easy, right? Because actually, when you have microservices, you've got more small things, and therefore you need things that can handle lots of small things. You can probably get away with sort of less effective tools for operating at scale when you've got a small number of large things. When you've got a large number of small things, you need good automation, you need good scripting. And we want something that supports Docker images. Two of these, actually, one of these platforms only supports Docker images. The other two have a lot more flexibility than that. We're going to look at three. We're going to look at Docker Swarm. This is sort of the freely available, out-of-the-box, multi-machine management for Docker that comes from Docker themselves. We're going to look at Mesos, which is the oldest tool here, probably the most mature as well, I'd argue, but sort of like a giant Swiss Army knife, like a really giant Swiss Army knife. So it can be hard to get your head around. And finally, we're going to look at Kubernetes, which is sort of the oldest, it's the sort of the oldest and the newest tool here. So Kubernetes is based on abstractions that Google use internally, but it's an open source clean room re-implementation of their internal approach to managing containers. So the thing to understand is Kubernetes is not what Google runs internally, because they're not stupid enough to let you have that for free. It's sort of their sort of external version of it. Start with Docker Swarm. Docker Swarm works like how most of these systems work, whereas you have the machines you're going to run your Docker images on, and you have some central controller. With Docker Swarm, we have a thing called the Swarm Manager. On your node, you have things called Swarm nodes, and the Swarm Manager talks to Swarm nodes. The nice thing about Docker is if you get used to the command line, so you know how to run, get process listings, get logs from a single Docker node, like on your machine, all of those, well, actually about 70 to 80% of all of those commands also work at the Docker Swarm level. So you can run those save-send commands like Docker PS, Docker log on the Swarm Manager, and it effectively multiplexes that out. So it makes it really, really easy for people that have used a single Docker machine management to start working with images in a Docker Swarm environment. It's the Swarm Manager's job to work out, OK, given what you've asked me to do, where should I go and put these nodes? So it's handling effectively what we call the scheduling. So it can scatter different Docker nodes, different Docker images, containers across all these machines for us. One of the things it uses is different scheduling strategies. This is a similar thing that both Kubernetes and Mesos have these as well, but it's worth diving into what a scheduling strategy can do for you. So for example, one of the sort of built-in scheduling strategies is bin packing. So bin packing is looking to optimize resource consumption. So based on the profile of an image you want to deploy, it's going to try and use up all the resources on a machine. So this is actually a very good approach for optimizing for a small number of machines. So in this example here, we've used up all the resources on this node, so we've gone over to the other node here, and then this node doesn't have anything on it at all. This could be a really useful thing to do if you're in a dynamic provisioning environment where you could turn Swarm nodes off to save money. So on Amazon, for example, just turn it off if you're not using it. This may not, though, make sense if what you actually want is resiliency, because you could end up with all the nodes of a given service on one machine, which would effectively give you a single point of failure. For something like that, you could then use a spread strategy. And when you say I want 5 instances, you spread, it will try and evenly distribute that node across all of these nodes for you. There's even a random scheduling strategy for just like spreading your stuff in random places. I'm guessing just for a laugh, because I can't really think why you'd want to do it. But anyway, other nice things, one of the best things about Swarm is the way in which it embraces the normal Docker toolchain. So some of you may have used Docker Compose. So this is an example of a very simple Docker Compose file. So this allows you in YAML format to sort of stand up a topology. So in this example, we're saying I've got one node, which is called web. It exposes some ports. It has a linked volume. And it actually has links, which is sort of a software-defined networking thing, linked through to Redis, so these two things can talk to each other. And by the way, I've got a Redis node, and that's the image I'm going to use. And this actually allows you to stand up little topologies for your individual services. It works quite nicely. And this stuff works as well on Docker Swarm. The one thing I would say, for independent deployability, you're deploying one service by itself. That means you want these Docker Compose files to just be the topology for one service. The exception, actually, is when you want to stand up, say, a whole collection of services for maybe test purposes. Then Docker Compose and things like it can be quite useful. So maybe when I stand up 5 or 6 services together for, say, a performance test, they can be useful there. So that's kind of handy. So what do we think of Docker Swarm? Well, there are some problems-ish. I used to say it doesn't rebalance. So if a node went down, it wouldn't necessarily redistribute your containers, and it wouldn't restart those failed containers. Those things have now changed, but it's fairly recent. And I say recent as in it was about 6 months ago that these things were fixed. The reason I'm hesitant here is because when you go into production on a platform like this, it kind of needs to work. And for me, when you've only had the ability to rebalance nodes when they fail or restart containers when they fail fairly recently, and I've heard some stories where it doesn't always work consistently, I get a little bit edgy. So those are new changes that are in there. That's a key thing you're looking for from a scheduling platform. You want the ability to run this stuff out, but what you're often really looking for is sort of the characteristics of what we call autonomic systems. You want the systems themselves to be self-healing. If I'm distributing 50 instances of a service, I don't have to come along every 10 minutes and check there's still 50 instances of my service. I want the scheduling platform itself to ensure that there are always 50 nodes running. So it's sort of like the auto-scaling groups in Amazon could do this for you. And Docker Swarm has only been able to do this for sort of the last 6 or 7 months. It plays very, very nicely with the rest of Docker. However, the case studies are very thin on the ground. Last time I did the research, and this was about 6 months ago, I found 2 case studies for people using Docker Swarm in anger. One was from Rackspace, one was from O'Reilly, who actually published my book. I found out that the Rackspace case study was where they'd used Docker Swarm to implement a platform as a service. The O'Reilly case study was actually a case study of them using the Rackspace PaaS that was in turn using Docker Swarm. So actually those 2 case studies were actually the same case study. Again, I'm a bit risk adverse. I want to, this is not necessarily where I want to take my risk. And so Docker Swarm is a bit, it's very easy to use and get up and running. But these are the things that give me hesitation about picking it as a production platform. Let's talk about Mesos. Mesos, again, is very similar, right? We have a Mesos master. The Mesos master talks to the actual machines where we're going to run our jobs. It talks to a thing called a Mesos agent. And at this point, we have to talk about one of the things that makes Mesos powerful and confusing. Because we have to talk about what Mesos calls a framework. A Mesos framework has really confused me for a while because I think of a framework as something that helps me use another thing, right? So like Hibernate is a framework for not understanding databases. But it's something to help me use something else. Frameworks in Mesos are something quite different, and it's not really helpful. We do this all the time in computing. We have terms that we understand what we mean, and then we decide in a different context to use that exact same word to mean something completely different, and it's not helpful. A Mesos framework is actually really a pair. It's 2 things. It's more like a plugin, would be a better phrase for it. What it is a scheduler, and that's a bit of software that would run on the master and works out how to sort of send out the jobs. And it's an executor, and that's an environment in which a job will run. So you can have one Mesos framework for Hadoop. And actually, the space that Mesos is often used in is the space of things like data processing, running Hadoop Swarm on Spark, Hadoop, Spark, and other MapReduce type style jobs. So I have a Hadoop scheduler, and so when I want to schedule my Hadoop job, I talk to the Hadoop scheduler, and it will support sort of my ecosystem. And then I run an executor, and my jobs run inside that executor. And so this is quite a pluggable system. This already is great because then you can start thinking that I could have one Mesos cluster that I could use for multiple different purposes, which is not necessarily the case for Docker Swarm. The framework that we would use for running microservices would be Marathon. So Marathon is a framework for running persistent, long-running jobs. So it's the thing that will ensure sort of the state is managed. So Marathon natively supports Docker images. It does support other types of applications running inside it. It is a thing that's going to maintain desired state. This framework model is really interesting because when a new technology comes out, you can actually drop it in and support it more natively. So for people like your data processing people that really know about running Hadoop jobs and that stuff, using the Hadoop scheduler is a nice level of abstraction. But you're making multiple uses of the same underlying hardware. This can actually make for a really good utilization of your physical resources. You can also think of other types of frameworks you can drop in. So Arithmetic is an interesting framework, whereas Marathon is for long-running persistent jobs that maintain desired state. Arithmetic is for really short-running jobs. It's sort of for running one-shot containers. So I run it, and it executes, and it dies. It's not very useful, is it? Hands up, though, who here has heard of Amazon Lambda, right? Arithmetic is kind of half of Amazon Lambda running now on your own infrastructure. It's the part that gives you a command line that lets you, or an API, to execute that container. All you need to do is stick an API gateway on top of it, and Arithmetic kind of gives you Amazon Lambda running on Mesos alongside. So now you've got your serverless architecture. God, that term annoys me, alongside your non-serverless architecture on your servers. Anyway, it's very confusing, but it's a very powerful model. So Mesos, it's great if you've got mixed workloads. It's also very interesting if you look at experimenting with their DSOS stuff, their data center operating system that provides sort of high-level abstractions for running things like Cassandra. You can mix all those workloads on the same infrastructure. It is very powerful. It is very fully featured. It is very widely used. There are some great case studies out there. How many people here have an iPhone? How many people here have used Siri on your iPhone? You are running on a Mesos cluster. So Apple did some talks like last year talking about how they use Mesos to scale Siri. They actually wrote their own framework rather than using Marathon. And they're running like 30,000 node Mesos clusters. So there are some great case studies at very large scale here. But there are lots of moving parts. There's a few things to get your head around. Let's talk about Kubernetes. Very new, very sexy. It's got Google. It's got some quite a few companies behind it. CoreOS are behind it. Red Hat's OpenShift v3. Which is basically a rebadged, packaged Kubernetes. Microsoft actually had one of the earliest examples of public-hosted Kubernetes on Azure. They got that out before Google. You can run sort of turnkey Kubernetes on a lot of hosting platforms. Similar architecture, very familiar architecture now. Now we're going to think called an API server. We now talk to things that are called kubelets. That's quite cute. I like that. Kubelets. Hello. And like all the other platforms, I've got some command line stuff, or I can make API calls to this central server, and that's going to schedule my jobs. And it deploys things as well. Now, the things it deploys are slightly different. We're not deploying now instances of a Docker container. We're actually deploying a thing called pods. So pods are a tightly coupled set of containers that will run on one node. So you might have 2 or 3 containers all together in one node, and that get deployed together all the time. You might also bundle in their configuration. This could be how you put your configuration files in there. So your configuration files could be one way of keeping them separate from the artifact to go in here, or for volumes. Pods themselves are kind of mortal. This isn't a conceptual service. This is just like I'm deploying a pod. So sort of when you schedule something, you're scheduling pods to be deployed. Now, this abstraction bugs me because it really feels like it's an abstraction based specifically on performance optimizations that Google use internally. You're not going to want to deploy pods with loads of services inside them because you want independent scheduling of your services, because you want independent deployment of your services. Therefore, when you have these pods, anything you really like to have in them very often are going to be maybe some configuration files or maybe like a volume. That's it. You're not really going to be combining multiple services together inside one pod. Kubernetes and Mesos and Docker Swarm all have scheduling strategies that allow you to say, when I deploy this service, could you try and deploy it next to this one if you can for performance optimizations? So you can already handle that stuff at the scheduling layer. So quite why you need it in pods has always bugged me a bit. And this is an internal abstraction that's been made external, and I don't think is always very helpful. And this isn't really a service either. This sort of feels like it's trying to be a higher level of abstraction than the other stuff we talked about, but it's not quite. But it does have a concept of a service, which Mesos doesn't really. And service definitions look like this. It's in JSON, which really annoys me. All their examples are in JSON. They support YAML too, and YAML's much more readable. Anyway, so here we see some stuff. We've got a name of a service. We've got some port information. This is so similar now to Docker Swarm. This again, like Docker Swarm, could be how, like Docker Compose, could be how we define our topology for our different environments. And so basically what a service is a mapping between a set of pods and some metadata and ports. So you see here this thing called a selector. And what that's going to do is say this service consists of any pods that map this selection criteria. And so on the machine, what's actually happening is you've got a little thing called the service proxy. And as pods are deployed, the service proxy is going, do you match any services I know about? Oh, you do? Right, I'm going to expose you. Actually, you've got other things inside Kubernetes that allow you to do things like sort of load balancing as well. So you can actually, which is, again, a nice feature. I thought this was great. OK, great. I really want to actually work at the level of the service. Conceptually, I think about scaling up a service. I'm talking about deploying a service. But in Kubernetes, it's all a bit different because you don't scale a service, you actually scale the pods. You don't deploy a service, you actually deploy the pods. And this sort of doesn't really fit very easily with me. And so actually, most teams that I've spoken to and the company I'm currently working at all end up with abstractions on top of this stuff to hide away this sort of odd, disjointed set of abstractions. Anyway, Kubernetes, it is slightly simpler setup than Mesos. I used to say simpler. I'm saying difference is not that great anymore, to be honest with you. Now I've played around with Kubernetes in more anger. It's also a more single purpose. You don't have this idea that you can do mixed workflows. It doesn't have the same pluggable execution concept that Mesos does. This is going to be more single purpose for you. It is a little bit closer in abstraction to a platform as a service, but it isn't actually close enough to Heroku-like PaaS for it to be really a big differential in my mind. It adds some things which are useful, replication control stuff, load balancing type stuff, but still not high enough level for me to say that I would definitely use it because of the high level abstraction. Pods can be a bit confusing. It is fairly new. It still does have issues. They had problems at the beginning of the year, I know, it's at the end of last year, where they couldn't actually scale beyond 100 machines. Those things have been fixed. People are working through. So they have got impressive industry support. I would say that you can run these things. You can go and fire up a Kubernetes instance on Google or on Microsoft. You can also do the same thing for Mesos, though, as well. So in terms of sort of summarizing this, if I'm thinking about these three platforms right now, if I'm interested in sort of a Docker-based deployment for my microservices, I pretty much take Docker Swarm out of the mix immediately. It might get there eventually. It's not there now. There's just not enough features there. I would probably suggest baking two of these off. And I would suggest going to somewhere like Google and just spinning up a Mesos instance, spin up a Kubernetes instance, and then just see what it's like to work with. And then think of that from the sort of deployment process point of view, and then try setting these up yourself and see what they're like. They all have little quirks and little interesting issues. I found it quite funny. I was diving into Kubernetes to see how it does secret storage, and the way Kubernetes stores secret information is in plain text, which is odd. Anyway, there are some legitimately hard problems here. But just to summarize, talking about the core principles of microservice deployment, independent deployability. Make sure that whatever you do around your tool chain, around your artifacts, around your platforms allows you to make one change to a service and deploy it by itself into production. One artifact for all environments. Don't rebuild artifacts. That introduces delay and it introduces a potential for error. So separate your topology from your artifact to make that work. And use the same deployment process everywhere. Consider using Docker images as artifacts because it gives you much cheaper isolated execution environments for your services. Even if you can't use Docker images, consider things like custom images. If you're on a cloud platform, think about Amazon AMIs. On DigitalOcean, think about droplets. I also actually shared with you a few criteria for selecting a platform. I will leave you with one just sort of caveat. This whole space is a little bit new and edgy, right? It's not just that the platforms themselves are new and have probably more churn than any other space in microservices, these deployment platforms. But the concept of what good looks like is changing for us all the time. So just be aware that I think it's kind of very important when you get to a certain scale of microservices that you have a platform that gives you these abstractions. But you may actually end up picking something and then revisiting your decision in a year from now. It is essential you actually bake these things off for yourselves. So you're going to go to a vendor, great, but don't go to just one vendor. Get at least 2 of them in to bake off. I'm just going to leave you some other things. If you want to buy my book directly from O'Reilly, you can use the code AUTHD. That gets you 40% off. I've also got a blog and a podcast at samnewman.io. And I think we're a little bit over, but I'm happy to go into the break to answer some questions. So, any questions? Middle row over there.
So one of the problems we have with independently deploying the microservices, the version dependencies of other microservices depending.
Yeah.
What are some tactics around that?
So you've kind of got, so firstly is knowing whether or not you're going to break somebody else, right? Ideally, you don't. Ideally, you do expansion-only changes, and you don't make backwards incompatible changes, right? That's ideally. The key thing is, even when you think you're doing it, you may get it wrong. So then I would say, think about your testing approach to catch those cases. You need to know it's going to happen. That's actually Beth Scurry there, is the second person down, who I did introduce. She did a talk a couple of days ago about a tool called PAX, which does consumer-driven testing. That helps catch the changes before they occur. But sometimes you have to introduce backwards incompatible changes. So then you've got 2 options. One option is, OK, I'm breaking you. You're calling me. I'm going to break you. Breaking you. So I'm actually going to leave the old version of me lying around, so you can still call the old version of me, and I'm going to deploy a brand new version next to it. And then I can give you time, so when you're ready to make your deployment change, to use the new API, to use the new backwards incompatible change, you redirect to me instead, then I can retire the old version. That requires work around service discovery, knowing what you're running, requires conversation about this stuff. And some places I've seen, they don't get the clients to update, and they just leave these things lying around, which has a bigger footprint. When you have multiple different versions of the same service lying around, they are effectively branches of code. If you've got to fix a bug, you've now got to fix it in multiple places. The other option is when you make a backwards incompatible change, is actually effectively on the same service version to have 2 different endpoints. So it's the same version of the code, but you should have 2 different endpoints. I've used both approaches. I prefer the latter because it simplifies my topology and avoids that sort of branching issue. But both are viable. Probably got time for one more question. OK. If you do think of anything else, I'm at Sam Newman. I hope you've enjoyed NDC. Please, as I say, do give feedback. And please do think about coming back next year. Tell all your friends and your colleagues. But I hope you enjoy the rest of today.